We're going to learn how to set tools for the machine. To set tools, we will use the CAM and the CNC application. Open the CNC and find the home position. Then open the CAM. From the option menu, set tools. All your tools are stored here. You can add, modify, and delete tools. Let's add a new tool. Click on Add. Each tool has a name. This name is for you to remember what tool this is. The tool I'm going to set, it's a drill, so I'm going to call it drill. There are many kinds of tools that work in different ways. Drills are for make holes. Drills will do holes on the start point of the line, or shape where you set the drill on. The next thing to set is the tool change position. This tool will be in position number 1. The first pocket on the left of the machine. Tools in position 0 will be loaded manually. Tools from 1 to 10 will be loaded from the tool change pockets. We will see later how. Check the diameter of the drill and write it in the diameter section. My drill is diameter 35. To set the Z offset, we must load the tool manually in the machine. Let's go to the machine. I'll now load the tool. And move the machine beside the piece. I move Z down until the drill is a little lower than the stone bottom. Go back to the CNC application and look at the Z position of the machine. In my case it's 266.5. Go back to the tool setting and write the Z position as Z offset. Next we set the depth for the pet drilling. Setting pet drilling to 3 will let the machine drill steps of 3 mm each time until it reaches the Z offset. Peg drilling put less force on the stone. I suggest you always drill with peg drilling, but if you wish to plunge your drill in a single time, you can set peg drilling to 0. Safe position, it's the height above the stone, where the machine will start moving at working speed. Above safety the machine will move at fast speed. For drills it's normally just a couple of millimeters. Next it's the spindle rotation speed and the plunging speed. You can check these parameters from the tool maker. I have a PDF for tools on the desktop. Let's open it. Check the drill RPM and plunge rate. I'll write the speeds in the CAM. And I'll save the tool. Now save the tool's settings. Next we are going to load the tool in the tool change, but first we need to remove the tool manually from the machine. Go to the machine. Move the machine up and remove the tool. Go back to the CNC application. Go to File and Reload Tool Table. You must always remember to reload the tool table after you change or add any tool. Now go to the MDI page. Write T1 M6. T1 means pocket 1, and M6 calls the tool change on the pocket. The machine will now load a tool from the first pocket. Let's see the machine. The first pocket is now empty, but the machine doesn't know it. We will do this fade tool change to load our tool in the CNC application. Notice on the bottom, a tool has been loaded. This is our drill. Now if we load the tool manually, we can let the machine put it in the pocket for us. Let's go back to the machine. I will load the tool manually in the spindle. And then back to the CNC application. Go back to MDI and type T0M6. T0 unload whatever tools is in the spindle right now, in his pocket. Let's see the machine do it. Your tool is now in pocket 1, and we can move to the next tool. Let's go back to the PC. Notice how in the CNC application, there is no tool loaded. Let's go back to the CAM Tools setting, and add a new tool. The next tool I'm going to set, it's a finger bit, of diameter 20. I'm going to name it Finger Bit 20. The finger bit, it's a profiling tool. Profiling tools are used to cut and profile your DXF shapes. You must remember to set the cutter compensation on your shapes when you work with profiling tools. This tool will be in the second pocket. The diameter is 20. Removal, it's how distant the machine need to keep the tool from the finished job. Removal, it's used because you cannot cut with the first tool in dimension, or there will be no material left to do the finishing with the other tools. So each tool will have smaller removals, until the last diamond tool will be on the finished line, with removal 0. Only polished tools have negative removal because they need to push on the stone to polish. You can find removal values in the tools PDF. Finger bit removal, it's normally 2 mm. Next is the tool waste. Stone tools are not forever, and as they cut they get smaller. The waste parameter is to let machine account for the change of the tool diameter, to always have your parts in dimension, and all your tools cutting. You can find tool waste on the tool PDF, or ask your tool supplier. There is another way to ensure that the tools always cut, by controlling the spindle ampere absorption, but is not a precise system and it's less used. For this finger bit I will set waste to 0.016. For the Z offset, you need to place the finger bit at working height, and read the position from the CNC application, like we just did for the drill. I will set my finger bit at 250. Safe position, like for drill tools, it's the distance from the stone where you can move at fast speed. I'll set it at 20. The spindle speed and feed rate are also found in the tool PDF. Let's set them. Plunge rate can be very fast, because the finger beat does not drill. Reverse direction, it's for better finishing. Passing some tools on the opposite direction will obtain a better result. For the finger beat, let's leave it at 0. The last two parameters are for oscillating tools, which are used to remove previous tools lines to let polished tools do a nicer job. Tool oscillation can obtain better cut and more uniform waste for the finger bit. My finger bit was touching the stone with the bottom when I set the Z offset. So I have to input -20 as oscillation parameter to let it go down 20 and work with the top. The frequency will be the distance for each step of the oscillation. I'll set 250 mm. Save. And save the tool settings. To load this tool in the tool change, use the same way we did for the drill, but write T2M6, because we have set this tool in the second pocket. Always remember that the T code will call for the pocket, and not for the tool number. Next, let's add some profiling tools. I have a half bull nose kit. I will show you how to set the first tool. Add a tool and give it a name. For this tool, the position in the tool change is 3. All other parameters can be found in the tool PDF or ask your tool supplier. It's important to measure precisely the diameter of the tools with a caliper. Let me show you how. You must measure with the caliper the smaller diameter. Let's go back to the CNC application. I will write the diameter. Then the removal 1.5 like in the tool PDF. Waste I will leave it at 0. Next is the Z offset. The Z offset, it's the most difficult parameter of profiling tools. I have prepared a DXF to try to explain the logic behind stone tools. Only with experience, you will set fast and good Z offset positions for your tools. Like for removal, each tool must get closer to the bottom of the stone. You can look at each tool position, and one by one set them closer to the bottom. Or you can check the position where each tool touch on the stone bottom. And starting from the last diamond tool, for each previous tool you remove 0.1 from the Z offset. In this way each tool will be higher, and the lines left by each tool will be removed by the next one. For polishing wheels, you must first pass the diamond tools, and then set the polishing wheels touching the shape left by the diamond tools. Because it's easy for polishing wheels to change shape, you don't want to set them in the wrong position. I will show you the position of the first tool. This is where I will set my first tool. Let's go back to the CNC application. Back to the CNC application. I read the Z position. For the first tool, I will remove 0.4 from this position and set it as the Z offset of this tool. Then I set the safe position at 100 because this tool has another tool below. RPM to 4800. And feet to 800. Plunge rate at 1000 to move down faster. I will save and add the second tool. Give it a name. The tool change position for this tool, it's also 3 because I have two tools one over the other. The diameter of my tool is 55.2. The removal 0.8 like in the tool PDF. Leave waste at 0. And let's go find in the machine the Z offset for the second tool. From where I was, I move up, and I find the second tool position. I will set this tool, like the last one. Now let's go back to the CNC application. Read the position. For this tool I remove 0.3 and write it as Z offset. For the next tool I should remove 0.1. And I should remove nothing for the last diamond tool. Now I set safe position at 25. RPM to 4800. Feet at 1000. And also plunge rate at 1000. I want this tool work in the opposite direction, so I will set reverse to 1. Let's save. What I want to show you is that this tool, it's tool number 4, but it's in pocket number 3. So on the machine to call this tool, you will write T3M6 and not T4M6. Next I will set a water slot tool. Water slot tools are set also on the bottom of the stone, but they work on the top. So depending on which stone thickness you set when you save the Jeep code, they will work on different heights. Water slot tools are mostly used to calibrate the stone to be exactly 20 mm. If you want to work with water slot in Jeep 42, set the diameter and write removal -25. This way the tool will calibrate your piece at the stone thickness height all around your job for 25 millimeters. All other parameters you can find in the tool PDF. I will save and move to the next tool. The last tools I'm going to show you are the tap tools. Let's add one more tool. This time I choose tap tool type. I'll set this tool in position 9. I'll set the diameter to 6. Tap tool's Z offset will be at the end of the screw. You have to move your tap tool to the finishing position and read the Z offset there. In this case, let's suppose it's 200. The tap will start from safe position above the stone. If we set a safe position 10 and later a stone thickness of 20, the tap tool will start from 30 over the Z offset and finish on the Z offset position. You could say that these tools are same to drills. The only difference is the K parameter, which is the step of the screw. Remember that tap screw is only supported up to 100 RPM. This is the end of this lesson.